Synthesis of natural rubber. Commercially, natural rubber is obtained almost exclusively from the Hevea brasiliensis tree, a tree indigenous to South America. When the bark of the Hevea tree is partially cut through, a milky liquid exudes from the wound and dries to yield a rubbery film. The latex consists of an aqueous suspension of small particles, about 0.5 micrometers in diameter, of cis polyisoprene, a linear rubbery polymer of high molecular weight. After collecting the top latex, rubber is recovered from emulsion by coagulation with formic acid, creating crumbs that resembled curds of milk. The crumbs are then washed, dried between rolls, and compacted into blocks. Another production method used to form natural rubber is also called smoke sheets, where the coagulum is pressed into thin sheets that are washed and then dried over smoky wood fire. The biosynthesis of natural rubber. Rubber particles are formed in the cytoplasm of specialized latex-producing cells called lactifiers within rubber plants. Rubber particles are surrounded by a single phospholipid membrane with hydrophobic tails pointed inwards. The membrane allows biosynthetic proteins to be sequestered at the surface of the growing rubber particle, which allows new monomeric units to be added from outside the biomembrane. The chemical process used to synthesize natural rubber. Addition polymerization is a chemical process used to join thousands of isoprene units together to form polyisoprene, or natural rubber. Natural rubber is an addition polymer that is obtained as a milky white fluid known as latex from a tropical rubber tree. Natural rubber is composed of the monomer isoprene, also known as 2-methyl-1,3-butadiene. Since isoprene has two double bonds, it still retains one of them after the polymerization reaction. Natural rubber has a cis configuration for the methyl groups. In addition polymerization, the monomers will have a double bond. The monomer of natural rubber isoprene has two double bonds as depicted. One of the double bonds in the monomer isoprene will become a single bond in the polymer natural rubber to allow for the bonding of numerous monomers. A double bond also moves from carbon 3 to carbon 2 to allow the monomer to attach to thousands of other monomers to construct natural rubber. Addition polymers also form more quickly than condensation polymers. Vulcanization of rubber. Vulcanization is a manufacturing process discovered by Charles Goodyear in 1839 to convert raw rubber into a tough, useful product. In this process, about 1 to 3% by weight of sulfur is added to raw rubber and the mixture is heated carefully. Sulfur atoms form crosslinks between adjacent chains of rubber polymer at the carbon-carbon double bonds. Crosslinks are the formation of covalent bonds which hold portions of several polymer chains together. Crosslinking binds multiple polymer chains together to form networks. The number of sulfur atoms in the crosslinks is usually 1 to 4. The cross-linking improves the properties of raw rubber, making vulcanized rubber a tougher material that is more resistant to oxidation, more elastic as the cross-linked chains can revert back to their original positions, more heat-resistant, which means the vulcanized rubber is less soft and sticky on warming, and less soluble in an organic solvent. Several products are made of vulcanized rubber due to its favorable properties.